This video covers section 3.3, solving exponential equations. An equation in form of y equals b to the power of x is called exponential equation. Here x is variable, b is the base. In this form, base always is a positive number and is not equal to 1. X is our variable that can be any real number. Let's solve some examples. Given f of x equals 2 to the power of x, evaluate the following. You see here f of x equals 2 to the power of x is a function, exponential function. If we evaluate f of 1, means substitute 1 for x. So we know f of x is 2 to the power of x. Imagine instead of x, we have a blank space. F of something equals to 2 to the power of that something. Now, if I have 1 here, so this one is going to be 2 to the power of 1. So f of 1 equals 2 to the power of 1 or 2. Now if I have f of negative 1, means in this blank space, I substitute negative 1. So I will have 2 to the power of negative 1. So it's going to be 2 to the power of negative 1. You remember when we have negative exponent, always we need to make that exponent positive. 2 to the power of negative 1, denominator is 1. If I flip over this fraction, exponent is going to be positive. So it's 1 over 2 to the power of 1 or 1 over 2. F of 0 again means substitute 0 for x or put 0 for this blank space. F of 0 means 2 to the power of 0. We know any real number to the power of 0 is 1. To solve an exponential equation, we have different methods. One of those methods that we can use is one-to-one property. In one-to-one property, if we have two exponential form with the same base, like a to the power of x equals to a to the power of y, if bases are the same, exponent must be the same. So it means x is equal to y. We call it one-to-one because if you have the left side, you can find the right side, or if you have the right side, you can find the left side. To solve an exponential equation using this property, one-to-one property, we have 3 steps. Step 1, we need to write our equation as this form, means an equation that both sides we have exponential form with the same basis. Then use one-to-one property because bases are the same, exponents are the same, and then here you solve this simple equation. Let's solve these two exponential equations. Part A, 5 to the power of x equals 5 to the power of 3. Solve an equation means find value or values for variable. Here variable is x. You see in this equation, bases are the same. So using one-to-one property, exponents must be the same. This means x equals 3. We solve this equation. Second example, 4 to the power of x plus 2 equals 4 to the power of 9. You see, bases are the same, so exponent must be the same. Means x plus 2 equals 9. Just we need to solve this linear equation. Subtracting 2 from both sides, x equals 7. In this example, we will use one-to-one property to solve each equation and round our solution to the nearest 1000. 5 to the power of x plus 1 equals 25. You see on the right side, we don't have the same base as the left side. So in this form, we need to work and write right side as exponential form such that base is 5. We know 25 means 5 times 5 or 5 squared. So left side is 5 to the power of x plus 1. Right side 5 to the power of 2. Now we can use one-to-one property. Bases are the same. So exponents means x plus 1 and 2 must be the same. We have a linear equation. Solving this linear equation, we find 1 as the solution for this equation. You see here we don't have any decimal. Next example, 2 to the power of x equals 16. Again, we need to work on the right side. We know 16 is 2 to the power of 4. Bases are the same, so exponents must be the same. Solution is x equals 4. In example 3, I'm going to solve part A. 2 to the power of 12t. Again, 4 means 2 squared. Now bases are the same. Exponents must be the same. That means 12t equals 2. Solve this equation. Divide both sides by 12. T equals 1 over 6. Since question asks us round the solution to the nearest 1000, so we can use calculator and find 1 over 6 as decimal. 1 over 6 or 1 divided by 6 is 0.1666. So nearest 1000 means 3-digit decimals. So answer is going to be 0.167. Let's solve part C. We have 8 times 25 to the power of 2x minus 1 equals 40. We can first divide both sides by 8. So on the left side you will have 25 to the power of 2x minus 1 equals 40 divided by 8 is 5. Now you see bases still are not the same. But I know 25 means 5 squared. So I can write left side as 5 to the power of 2 to the power of 2x minus 1 equals 5. Now using the rule, these two exponents will multiply by each other. So we will have 5 to the power of 2 times 2x minus 1 equal 5 to the power of 1. Now bases are the same. Using the one-to-one property, you will have exponents the same. That means 2 times 2x minus 1 equals 1. Just you need to solve this simple equation, distribute property. So we will have 4x minus 2 equals 1, or 4x, if you add 2 to both sides, 4x equals 3. Divide both sides by 4. X is going to be 3 over 4. This is exact value. If you use your calculator and divide 3 by 4, then round your answer to the nearest thousand, you're going to have estimated value.